Hi, in this first video of the hsbDesign for Revit Beginner Series, we're going to take a look at the Framing Styles editor and how to define your own framing styles. hsbDesign for Revit works with the structural framing family. To get the default types, HSB Cut Beam and HSB Cut Sheet, you can open up the Framing Styles editor, once up here in the HSB Stick Frame ribbon, and close it right after. As you can see, I've already created different types with different sections which I'll now use to create new framing styles. To do so, I open up the Framing Styles editor. In here, you have to define aliases at first. The aliases are used to map materials to them and then use the aliases for each single zone to define which material will be distributed in this specific zone of the framing style. When adding aliases and naming them, we try to use the material that they will represent. So this alias is for the studs, the next one is for plywood, and we have another one for OSB. In the Framing Styles tab, you first have to add group. For groups, you can use different types. There's wall, floor, and roof groups. It's important to select the right type because we'll need this later on for connection details. This group will contain the exterior walls framing styles. So we add a new framing style to this group, and for each framing style, we can give a fitting name. This one will be E1 for exterior walls and a description. I like to use zones for this, so OSB, then a 38 by 184 stud, and again an OSB. You now have to map the materials to the aliases. So we'll use OSB for OSB, plywood for plywood, and for the studs we're using a 38 by 184 beam. In the Zones tab, Zone 0 is already added. Zone 0 is the structural zone, which will later on also be referred to as the core layer. So we have to define a zone filler for each zone. The zone filler defines how the material that is mapped to the alias will be distributed in the zone. For Zone 0, we're using the beam distribution filler. Up here, you can set up the material by selecting the right alias. So Zone 0, we want to have the studs. Because the stud material is a type parameter, you can't change the width and the height in the Framing Styles editor. Later on, you will see that we can do this for instance parameters, just like the sheet for example. Furthermore, you can set up the spacing of the beam. And if you don't know what a property is about, you can hover over the question mark and get a visual representation. So delta is the offset of the first stud in the framing style. Next, you can add a beam code. We'll use ST for the studs. This is really important because later on, when we define the details, we can use these beam codes to manipulate specific beams and sheets. You can also set up the start of the distribution. You can either start on the left, on the right, or in the middle, or on the highest point, which makes sense in a gable wall. And you have some more options which we'll get to in a later video. For now, we're using left. You also have the option to add insulation layers. Down here, you have a visual representation of the framing style, and you can switch between different views over here, or you can rotate this with the right mouse. You can also zoom in. And if you zoom in, you can see that we have an offset over here. When we go into the top view, you can see it even better. And this is because in the inventory we're using the default beam for default beam. And the default beam is used for the bottom plate. So to fix this, we can use the same material as we're using for the studs, for the default beam. So we're using the 38 by 184. And as you can see, now it is fixed. We now want to add a new layer to the exterior side, and this one will be a sheet distribution. You also have the option to add, for example, sidings or battens to this. But from now on, we'll use the sheet distribution, and we're using the alias OSB for this one. So, because the material that we assign to this alias is an instance material, we can change the thickness in here. So we can change it to 15, for example, but we'll leave it to 12. Because of the instance parameter, you also have the option to change the width and the length in here. Furthermore, you could set specific width and lengths for the first and the last sheet. You could set minimal sheet width and different gaps. As for the beam distribution, you have the option to set up the distribution, so you could set up the start of the distribution, this time just for left, right, middle and highest. Highest only makes sense if you're in a gable wall. So, you have the option to define how the sheets are behaving at openings. So if they're twist, if they're rotating, or if they get split. And you have the option to make the sheeting staggered. Making the sheeting staggered means that the splits are not at the same height. And furthermore, you can make it continuously staggered, which will minimize the waste. For the continuously staggering, you can define a minimal split difference. You also have the option to add a blocking or add support beams behind splits. If we move into this view, you can see that the split is always on the second beam. This is because the beam spacing is half of the sheet width. If we, for example, change the sheet width to 1500 millimeters, we'll have no stud behind the sheet split, and this is just not ideal. So to fix this, we can use rely on. So we can make zone 0 rely on zone 1. What this will do is that there's always a beam added behind the sheet split. So we have the beam spacing of 610 millimeters between these two beams. Then we have the stud behind this sheet split. And then again 610 millimeters till the next beam. So the sheet splits are now fixed points. So we'll set the width back to 1220 millimeters. And we'll add another zone on the interior side, which will also be a sheet distribution with OSB as well. And we're also making the sheeting continuously staggered. We can now add descriptions to the single zones. These descriptions will later on be visible when matching the framing styles to a wall, so we know which material is used in each zone. So, this zone is using an OSB 12. This zone contains a 38 by 184, and this zone contains an OSB 12 as well. After this is done, we want to add a new framing style, and this one is again for walls, but this time for interior walls. And to make our lives easier, we can copy this framing style of the exterior walls and drag and drop it down here to the interior walls. Change the name of it to I1 for interior walls. And now we're going to change to inventory materials. So we're going to change the default beam to 38 by 89 because this is the size of stud that we want to use. And we also need to change this in the description. So we have OSB 38 by 89 and OSB. So if we now move through the zones, you can see that if you zoom down in a preview, it's all right. So the bottom plate is the same size of the studs. And if you take a look at the thicknesses, the thickness of zone 0 is correct as well. We only need to change the description to 38 by 89. And we're done with the definition of the framing style for our interior walls. In the next video, we're going to take a look at the edge details to finish our configuration of the framing styles. I hope this video helped you get an introduction to the Framing Styles editor and learn how to create your own framing styles. See you in the next video of the Beginner Series.